Hi, I was asked to create a small video on how we can use the P scores. P stands for probability, and how we can use the P scores or P values as they know to confirm a hypothesis. To do all this, I want you to remember that there are some steps we have to do first. So first we have to find the mean scores from our sample. And from these mean scores we have to find the standard deviation. And from this standard deviation, we have to find what in mathematics we call it sigma. And then from this, find, that means how many standard deviations our mean scores is showing that deviation, and from that standard deviation we have to find the Z scores. That means how many standard deviations our hypothesis is away from the mean, and after that we need, after the Z scores, we will be able to find the probability. That is the P value. So I will guide you how to do all this based on the following scenario. We are talking about a sample of 87 participants who have slept certain hours using white noise, and some others who used non-white noise. And we are checking the mean scores of their sleepiness, the mean scores of the Epworth sleepiness test. The sample was given, it is 6.9 and 7.2. I was given only the mean. However, I need the whole sample to be able to find the standard deviation, because as you see, I have the means of both, but I need to find the standard deviation of one at least, so I will be able to test the hypothesis. I want you to remember that I won't be able to work with these numbers. I will change these numbers with something else according to our class sample, because I have the Excel of my class sample. And I will show you how, using the Excel, I can find from the mean the standard deviation. Usually, in order to be able to find the p-value, we are given both means and standard deviation. We enter our data. For example, these ones, we enter our data. I'm going to bring it here so you can see. And from the data in my class, this is the Epworth mean score, the light blue. So I have entered all the data, and I have the mean score from the white noise, and the non-white noise group. This is the mean score of the non-white noise. I'm going to open this, but I need to be able to find, this is the white noise and this is the non-white noise scores. So I'm going to use different numbers than yours. However, I want you to understand how we have to find the standard deviation. I'm going to show you how we're going to find the standard deviation. I want you to click on your Excel, have all the data. I'm going to make it smaller so you can see what I'm doing. I want you to have all the data entered. Sorry about this. So I want you to have all the data entered, the sleepiness. And while this is mean, I'm going to color this in a different color. And show you how I'm going to enter it there. So I want you to click here and write equals ST, and you click that, ST dev standard deviation P of my population, or standard deviation of my sample. So I don't want the whole population, except if your whole population is your whole sample. It's not much difference actually in statistics. I don't want to make your life harder. So could you please use this, standard deviation of my sample? It's the best way. So click that. And I want you to type here ST dev dot S and open brackets. Okay, and I want you to highlight from here to there, close your brackets, enter. So here you have your standard deviation. If I enlarge it, you see that the standard deviation here is 9.2. Okay, so let's go back and discuss something about the standard deviation. We need to take a normal distribution. I hope you remember what a normal distribution is. So if I have a normal distribution, let me change the color, nice color. I have my nice bell, and if this is my mean, in my sample my mean was 21.21. I'll do it round up, 21.22. Sorry. So my mean was 21.22. The standard deviation, one standard deviation here and one standard deviation there, the 68% of my sample is at 9.27. So 9.27 positive and 9.27 negative from the mean. So in order to be able to sort this out, I need to find the S, the sigma. So the sigma actually of my sample is my standard deviation, okay, which is my sample standard deviation, over the square root of my sample, and your sample was 87 participants. So the square root of 87. So you have to go and say, what's that? 9.27 over the square root of 87. We need to bring a calculator to sort this. So let me brought the calculator. I hope I'll open it here. Yes, I hope I'll open it a small part. And you can be able to see what we are doing. Sorry. I need to open this, and at the same time I need to open this. So I'm going to enter here so you can see what we're entering. 9, I have to divide 9.27. So it's a simple division. I don't think I'm able to. 9.27 divided by, I need to find the square root. I have to enlarge it to find the square root. Sorry, wrong choice. I have to do the calculation somewhere else. My computer doesn't have calculation. So let me do the calculations manually. So it is 9 point. You have to understand that. I'm assuming that the square root of 88 is 8 times 8, 64, so it is 8.1. So if I divide 9.27 by 8.1 is approximately 127, 107, let's say 2.5. Okay, so if this is 125, this is the sample, the whole sample's S sigma. Okay, standard deviation. Now, in order to be able to move further, I have to move from this to find the z-scores. It's about time now to discuss my hypothesis, and I want to remind you that we are not using these numbers. I need to use my numbers from where I found my standard deviation. I need to open this again and to remind you that my 21.22 I will remember, and the other one I remember 15.01. So the white noise mean for me is 21.22, and the non-white noise mean is 15, let me check it again, is 15.1, 21.22. So 15.1. So in order to be able to prove my hypothesis, now I have to find the z-score. The z-score means I need to know how many standard deviations, like 1 standard deviation, 2 standard deviations, 3 standard deviations, how many standard deviations my sample and the probability is to prove my hypothesis. Okay. Remember that. I'm stopping here. I'm ready to find how many standard deviations are moving across. Before this, I need to start discussing the concept of null hypothesis and my hypothesis. Okay. I say that my null hypothesis is that the white noise does not make any difference in the sleepiness. Doesn't affect the mean scores of the sleepiness Epworth test. And my other hypothesis is that the white noise, remember I'm always working with one, not the other one. Null hypothesis or zero hypothesis, null hypothesis means that the white noise does not make any difference, does not have any effect in the sleepiness. Whereas the hypothesis 1 is that the white noise does make a difference, does have an impact in these scores. So let's assume that this is correct. I want you to understand that when we're working with these concepts, if I'm going to prove that this is wrong, then, sorry, I got it right. If I'm going to prove that this is rejected, or it is wrong, or it's not accepted, then by default, this will be accepted. Okay? So it has to do what is your hypothesis. Do you believe that the white noise does make a difference? So, if you want to believe that the white noise does make a difference, you have to start by the opposite. You have to start with the null hypothesis that white noise does not make any difference. Okay. So let's start working on this and discussing how we're going to find the Z-score now. Okay, so I want you to remember that this is the, this is the one mean score, and this is the other. And I want you to remember that my standard deviation for the whole population is 1.25. So this is what I'm going to use now to find the Z-score. It's a formula, specific formula. So this is my one hypothesis, okay, the white noise and the non-white noise. So I'm going 21.22, take away 15.01 over 1.25 equals, I'm going to find now, if you remember, how many standard deviations from the mean my sample should be. So I'm subtracting, that's 6.21 over 1.25. And in this case, I need again to do the division. You have to use your calculator. I don't have a calculator at this stage, unless if I can try online to find an online calculator to do the division quickly. Sorry about this. Okay, probably that will do more than anything else. Let me see the numbers again, and the numbers are 6.21 divided by 125. So I'm writing here 6.21 divided by 1.25, and the answer is 4.968. That's very good. It's very close to 5. So you have to see that it is highly unlikely what we're going to prove here. 4.9. Okay, that means if we're going to discuss it again, 4.95 standard deviations, okay, from the mean. So if this is my mean, okay, and this is my nice bell, okay, I need almost 4.9 standard deviations across to have something that it won't prove my hypothesis. So I want you to remember the theory of the standard deviation. Okay, I don't know if you remember from your mathematics the rule 68 and 99.7. 3 standard deviations, that this is 1 standard deviation, 2 standard deviations, 3 standard deviations from the mean, okay? It is the 99.7% of my population. So I'm not only 3 standard deviations, I'm 4, and I am 5 standard deviations away from that. So if I'm going to have something that will not prove my hypothesis, it's somewhere over there. So it is very, 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 very far, far, far away. So what I want to say is that if we have 5 standard deviations far away, so far away, 5 standard deviations. This pencil is killing me. Sorry about this, guys. So we have 5 standard deviations so far away from the mean. What's the probability? What's the probability to have a sample, a random sample, far, far, far away, so far away from the 99.7%? It's even here, it's 100%. Okay. So actually, we are even further. If that's the 3rd standard deviation and this is the 4th standard deviation, even further. So it is highly, highly, highly unlikely to have a sample that will fall outside here, and we will prove this null hypothesis because we're working to prove the null hypothesis. So, what's the probability to have something out there? It will be 0.0000001. Okay, so 1 in what? Million? I can put another 0 there. So, a billion? It's unbelievable that we cannot actually find something so strong. So, I'm persuaded now that there is it's highly unlikely. It's very high probability that this is not accepted. So if this is rejected, not accepted, this is what I'm going to accept. Okay, that white noise does make a difference. Guys, I want you to remember that this proof is based on our data. I want you to remember that your data are 7.2 and 6 9. And if I remember correct, Miss Armfield told me that the white noise is 6.9 and non-white noise, it is 7.2. So you need to find your standard deviation, which probably has to be different than this, and then go 6.9, take away this divided by 1.27, whatever is your standard deviation, you have to find it. Come and help you find it. And here I want you to remember that will be negative, okay, negative 0.3 divided by something. I don't know what will be your standard deviation according to your sample. And this, okay, this probably for you, you see how big is this number for me? So this probably for you will have a huge difference because your standard deviation won't be there. So if you want really to solve this with the p-values, you need to come and see me with these numbers, with the 0.3, negative 0.3, so we are on this side, okay, and a different standard deviation, this can be completely different. You may actually support your null hypothesis. I hope that will be enough for you to understand what you're doing. I love this kind of use psychology. You're going to go for a merit if you're going to do that, I think. However, you have to be very careful with your numbers and the null hypothesis. Okay, good luck. Come and see me.